All right, friends, let's consider this following story, okay? So let's assume we have a urn of marbles. We will have so many, we'll just say for fun right now, 5 white marbles and 4 blue marbles, okay? So we have 4 blue marbles and what did I say? 5 white marbles. Okay? We're going to assume that these white ones are the tagged in this story. Okay? So really, we don't even care if the others are blue or whatever. They're just not white. All right? The next thing we're going to do is we're going to grab K of these marbles or balls, whatever we want to call them. We're going to let X represent or count the number of white marbles I grab or tagged, whatever I've tagged in this set. The number of white, I'll put in parentheses, tagged here so we can extend this beyond marbles, I grab. Okay? Now, in this example, what can X represent in this case? Right? So it really, in general, it's going to depend on the number of K that I grab. So let's say K here is going to be 3. If K is larger than the number of tagged, then that's going to determine the values that X can take on, right? So, but in this case, we can clearly see we have enough white balls to grab all of them being white. We also have enough non-tagged balls that none of them can be white, right? All these, the number of tagged or untagged, here, let's put this right here, untagged, determines the values that X can take on. All right? But in this case, X can be 0, 1, 2, and up to 3, right? I'm limited by K and by the number of tagged and untagged. All right, so let's define, okay, so if this is my random variable counting the number of tagged, we've already seen this problem before, but it actually represents a common distribution, which is called the hypergeometric distribution. So if you remember, let's just make our chart and see if we can generalize, right? So if X is 0, then what is the probability X takes on that value, right? Well, this is just a counting problem. So I'm grabbing from the tagged ones, which are 5, or from the white ones, 0. I'm grabbing from the remaining ones that are not tagged or untagged, in this case 4, all 3 of them that I pull, right? And all this is over, what's the total in here is 9. Choose 3. Oops. Right? So that's what it is in this case. 1, what is that? Well, that means I'm going to, of the 5, pull 1. Of the non-5, pull the other 2, all over and choose, 9, choose 3. All right, we get that. We get that all the way down, right? So I bet you could figure this out. Let me just finish it up for completeness sakes. 4, choose 1, over 9, choose 3. Last one, 3, is 5, choose 3. 4, choose 0. All over 9, choose 3. Okay, so we understand it in this example. So let's move over here and generalize. Switch to my, fun purple color. So I'm going to make another arbitrary urn, and we're going to have some number of tagged. So first of all, let's use this notation. And different books use different notation, but it's the same idea. Okay, so sometimes this scenario is framed not with balls or marbles in an urn, but in a population, where here's the scenario. You have some population, we'll say N is the population of elk, okay? And we capture some of them, So this is like recapture, capture, recapture. We capture some of them and we tag them. All right, and so W, which is going to be the tagged elk once we capture them, however many that is, I'm just going to randomly put some here, which means N minus W is the untagged. So in our last example, those were our blue marbles. So W is our tagged, N minus W is our untagged. Okay, now we're going to go back and we're going to recapture K of them. Okay, so K is the amount, it was 4 in our last example. No, sorry, what was it in our last example? Yeah, 3. 3 in our last example. Here, we're just going to say arbitrarily, we're going to, K is the amount that I recaptured. Okay? We let X be the number of tagged elk recaptured. Okay, so this is the same scenario as the marbles. So in general, what is our PMF? Right, the probability X equals X. Well, of the tagged, we're going to capture X of them, right? Now, we got to figure out this one because I don't have the B anymore. I've got this in terms of the whole population. Well, the number of untagged is the total population minus the tagged ones. And the number that we're going to grab from there is the size of the grab minus the ones that I were tagged, right? So maybe one of them was tagged and 2 of them weren't. 2 of them were tagged, 1 of them wasn't. Okay, we're 3. And all of this is over the total population, N, choose K. So in terms of our blue marbles and white marbles, we would have said the probability X equals X is W choose X and then B choose K minus X, right? All over W plus B choose K. So those are the same thing, right? That represent, we can illustrate it with 2 different examples. So when you come across a hypergeometric distribution, you want to be able to ask yourself, can I frame this as the balls in the urn and I'm grabbing them? Or can I frame them in this capture-recapture scenario? Okay, so here is our PMF, which I feel like we talked about before with the negative binomial, I feel like it's better to just count, to recognize that this is a counting problem and count than to try to memorize all the variables and what stands for what. So I'm just going to say here, just freaking count. Okay, we call this, let me put our notation, the hypergeometric. I'm going to abbreviate hypergeometric, and it has, well, in this scenario, it has 3 parameters: the total population, the tagged elk, and the number of elk that I recapture, right? That's the total pop, that's the tagged, and tagged is really just the thing that I've decided is success, right? It's the thing that I'm counting, and that is the pull or the recapture. Okay? Now, how does this differ than the binomial and all the rest, right? I'm still counting the number of successes here. So this is still the number of successes. Ooh, try to spell out successes. And K is the number of trials, so I do have a fixed number of trials, right? So let's write down what's happening. We do have a fixed number of trials. That's our K in this case. We do have 2 outcomes. Success, which is grabbing one of the tagged ones, and failure, which is not grabbing a tagged one or an untagged, right? Well, what's different is every time I pull an elk out of the population, the probability that I pull another tagged one is different than when I did it in the first place, right? X is not independent, right? right? So my trials are not independent of each other, right? The probability of success changes after every poll. All right, so that is a key difference in the hypergeometric distribution than in a binomial, geometric, negative binomial. It's an, or Poisson. This is our not independent discrete distribution. That's it.